It won't be very long. Oh, I did what I did last time. I didn't share my screen. They're hearing all that, but okay. Am I recording also? I am recording. All right, so let's see if this works. Okay, so anyway, so one of the charts is just the distribution shapes, and this is the one, I know I didn't talk about bell-shaped very much other than saying it was a hill, but with bell-shaped, if any of you have any family members who are in college right now and you've heard that their professor grades according to the bell curve, have you ever heard that, like on TV or anything like that? What that means is, like, if he's got 30 students, he makes his curriculum or his test or whatever based on the bell curve. He predetermines that you know, the majority of the students are going to make C's, so he makes his test so that most of you make C's and some of you make B's and D's, and then few of you make A's and F's. Okay, so I mean, I don't like that, but you know, I'm not a professor. Now, when you have a symmetric graph, remember symmetric, it's the same on both sides. The mean is going to be equal to the median. The opposite of that is also true. If it says this graph has a mean that's equal to the median, then that automatically means that it is symmetric. Okay, you cannot have a skewed graph where the mean and the median are the same. A skewed graph, if it's skewed to the right, that means most of the data is pushed over to the left and the mean is greater than the median. On the test, it said compare the mean and the median, and some of you had to calculate it or did calculate it, but it wanted you to look at the shape of the graph. Okay, it wanted you to see, oh, it's symmetric, so that means they're equal, or it's skewed to the right, so that means the mean is greater than the median. It's skewed to the left if most of the dots or most of the data is on the right-hand side, and there the mean is going to be less than the median. When you're talking about a skewed graph, you want to use the median as the measure of center that you discussed, kind of like when I said I would buy you guys Sonic drinks if the class had about an 80 average or an 80 test score, and we had most of y'all made 80s, and then one of you made a 20, you guys would probably say, hey, we use the median and not the average. Okay, because when it's skewed, that, remember, the outliers really change the mean and not the median so much. Since we use the median as the measure of center, that means we want to use the IQR as the measure of variability. Bimodal doesn't mean that two numbers have the same amount of dots. It means that there are two numbers that have the most dots. They have to have the same, but it's the most. This is bimodal not because 4 and 5 have the same number of dots, but because 3 and 6 have the same number of dots. That are the most, yeah. Okay. So let's look at this next one. Okay, measures of variability. All right, so variability is how the data varies. So it's how spread out the data is. We've talked about, like, if every single one of you made the same exact score, there's no variability. I mean, the variability is 0. The further out from the mean that you get, the higher the score is going to be, the IQR, the standard deviation, or the mean absolute deviation. With box plots, you have to use the IQR because it's the only one that talks about quartiles. Now, you could take a dot plot and make a box plot from it, but you can't find the IQR with a histogram. They have to tell you the information. Kind of like that number 7. We couldn't figure it out based on the histogram, but it gave us that table that had the information that we needed at the bottom. Remember to find the IQR, it's Q3 minus Q1, because with a box plot, the variability is based on the middle 50%, because we're talking about the spread from the middle. You don't have to calculate mean absolute deviation or standard deviation. They both are used interchangeably in this curriculum. It might mention standard deviation in one problem, but mean absolute deviation in the other. It's pretty much the same thing. They're just calculated differently. The bigger the numbers for the IQR, the MAD, or the standard deviation, that's the further it's spread out, since it's based on how far away from the mean it is. And then outliers. Like I said, an outlier is going to be a single number. It's either going to be the minimum number, the smallest number, or it's going to be the biggest number. It's not going to be a range of numbers. It's not going to be the two smallest numbers. If there are two dots on the smallest number, then that's not an outlier. An outlier is a single number. The minimum is an outlier if it fits that formula. So you got to find the IQR. 95 minus 80 is 15. Then you see if 45 is less than Q1 minus 1.5 times the IQR, and it is. So that means 45 is an outlier. The maximum would be an outlier if it fits that formula. So in this instance, I just give you the 5-number summary. But we need to check to see if 70 is an outlier. So we plug that in, and we get 70 is greater than 70, which is not true. 70 is not bigger than 70. So it's not an outlier. It's right on the cusp. If the maximum was 71, it would be an outlier because it would be bigger than 70. Okay.
May I have your teacher, please? Teachers, please dismiss the ninth grade girls basketball team.